I'm Anil Kumar sharing with you a test question on rationalizing complex expressions. The question here is to write the following in a plus bi form. So we have two examples here. You can always pause the video, copy the question, and then look into my solution. The first one is 4i plus 1 divided by 1 minus 4i. The other one is 3 minus 2i divided by 2 plus i whole square. So to write in a plus bi, we can rationalize and we can write the first expression as 4i plus 1 divided by 1 minus 4i. We need to multiply and divide by the conjugate of the denominator, which will be 1 plus 4i, correct? Now when you expand, what do you get? This is 1 plus 4i whole square. That means you'll get square of the first term, which is 16i square, plus twice first and the second term, which is 8i, plus square of 1, which is 1, divided by a square minus b square, which is 1 minus 16i square, correct? Now I square is minus, so we get minus 16 plus 8i plus 1, and in the denominator we get 1 plus I square is minus 1, so we get 1 plus 16. So you can now write this as 1 minus 16 is minus 15. The denominator is 17, so I can write this as minus 15 over 17 plus 8 over 17i. Right? So clearly a is the constant term here, the real numbers, real part, which is minus 15 over 17, and the imaginary part b is 8 over 17, correct? So we have done the first one. Now I'd like you to try the next one, which is 3 minus 2i divided by 2 plus i whole square. Now the difference here is that denominator has whole square thing. So how should we do it? This time when you rationalize, you should be multiplying and dividing by 2 minus I whole square, right? So we'll do this as 2 plus I whole square times 2 minus I whole square divided by 2 minus I whole square. So that is a critical step. Now let's expand this and then multiply. 3 minus 2i times, so we'll apply the formula a square, a minus b whole square is a square, which is 4, minus twice ab, which is 4i, plus b square, which is I square, which gives you, let me write first I square. Okay. Now denominator gives us, it is kind of 2 plus I times 2 minus I whole square, right? Squares. We could do like this. Now you can simplify this a bit. I square is minus 1, so that gives you, let's rewrite, 3 minus 2i times 4 minus 4i minus 1 divided by, now here it will be a square minus b square, square of 2 is 4, and square of I is minus 1, so that gives me plus 1 in the denominator. And then we have whole square here, right? So let's multiply these terms. Before that, let me combine them. So we get 3 minus 2i times 4 minus 1 is 3 minus 4i divided by, this is 5 square, which is 25. Now when you multiply, 3 times 3 is 9, 3 times minus 4 is minus 12i, with minus 2i gives us minus 6i, minus minus is plus, 2 times 4 is 8, I square over 25. Now this is, now 8i square, that is negative 8, right? So you get 9 minus 8, and here we have minus 18i over 25. Now 9 minus 8 is minus 1, so we get, let me push this a bit here. So we get minus 9 minus 18 will be minus, 9 minus 8 is minus 1. So we get 1. 9 minus 8 is 1. And then minus 18i. So I can write this as 1 over 25 minus 18 over 25i. So this expression could be written as 1 over 25, that's the value of a, minus 18 over 25i. So it is very important to understand that if you have something square, then you have to multiply and divide by the square of that conjugate, right? So that is what I wanted to discuss with this example. I hope this is clear. Feel free to share your comments and your views. If you like and subscribe, that'll be even better. Thank you and all the best.